Therefore, nth term of any AP is always linear polynomial. If you don't know which term you are talking about, got the point here? In the same way, you already know that sum of all the terms of AP till general term AN, which is unknown. Say which is unknown here. So, yeah, sum of all the terms of the AP till the general term AN is given by the formula Sn equals to n by 2 into 2a plus n minus 1 into d. You already know this thing here. So, let's have a look at that thing. So you know that if I want to add all these terms, that is first term plus second term plus third term plus fourth term, sorry, third term plus fourth term, dash dash dash, etc. till the last are the n term. We don't say it as last term here. We call it as general term or n term. Right. So this sum of all the terms of the AP is denoted by the symbol Sn. That is sum of all terms till the general term n. Till the general term n term here, we have taken as Sn is given by the formula n by 2 into 2a plus n minus 1 into d. Right. Now, let's do some multiplication here. Let's multiply this thing to all the things in the bracket here. So n by 2 into 2a, n by 2 into 2a plus n by 2 into whole term here. That is, what the whole term here? N minus 1 into d into n by 2 into n by 2. Right? We have multiplied n by 2 for both terms present in the bracket here. So 2 to cancels here, left with n into a. N into a plus, you can multiply n by 2 into d as nd by 2. It will be nd by 2 to n here. So nd by 2 into n will be n into n square. So d by 2 will be d by 2 1. D by 2 1. Minus again minus. So nd by 2 into 1 is same thing nd by 2. Okay. You already know that once you know the value of a and the difference between the two successive terms, they become the constant here. They become the constant. Counter to how many terms you are adding the series here, then n becomes the variable. ಹೌದಾ ಕರೆಕ್ಟ್ ಅಲ್ಲಿಗೆ if you know a and d, then they become constant values. We don't know up to how many terms, up to what terms or up to how many terms you are adding the series, then n becomes variable here. N becomes variable. In that case, in that situation, you can say n square into d by 2. Let's rearrange the terms here. So plus we have n into a minus nd by 2. So n into a minus nd by 2 here. So is equals to n square d by 2 plus, we can take n as common here. So n, if you take n as common here, then you can write a minus d by 2 within the brackets. Isn't it so? Plus you can write 0. You can write 0. As there is no thing here, you can write 0 plus 0. It doesn't alter the RHS of the equation here. So Sn will be given by n by 2 into 2a plus n minus 1 into d. Nothing but ಹಂಗಂದ್ರೆ ಒಂದೇ ಹಿಂಗಂದ್ರೆ ಒಂದೇ ಏನು n square by 2 into d or n square d by 2 plus n into a minus d by 2. As you know already, a and d are known values here for a given AP, where the number of terms is unknown. N becomes variable, a and d becomes constants here, known values here. Then I can say we have n as variable to the power 2 here, and plus, sorry, n as variable to the power 2 here with its coefficient to d by 2, with its coefficient to d by 2 plus n as variable to the power 1 with its coefficient to a minus d by 2 plus another constant value which is always be 0 in this case, in the case of sum of n terms of the AP. If you compare this form to the general form of quadratic polynomial, you know the general form of quadratic polynomial. So general form of quadratic polynomial. Quadratic polynomial is given by ax square plus bx plus c, where a, b, c are the constants. A is with x square, it is called coefficient of x square. B is with x here, so b is called coefficient of x here. C is with x to the power of 0. You can take it as 1 here, that is c as a constant term. So we can say ABC are constants here, which are real values, and x is the variable here, whose value is unknown here, right? So for the variable x which has power 2, we can call this as quadratic polynomial here. Just compare this thing and this thing here. We have variable x, we have variable n here, to the power 2, to the power 2 here. We have coefficient to d by 2, we have coefficient a here, plus we have variable n, we have variable x here. In the same way, we have coefficient of n, that is variable, as a minus d by 2. Here it is d here, and we have constant 0 here. We have constant generally taken as c here. So we can say sum of n terms of AP is a quadratic polynomial whose which can be expressed as n square d by 2 plus n into a minus d by 2 plus constant, that is 0. Did you get the point? Yes, sir. That is sum of n terms of the given AP will be a quadratic polynomial. Thank you.